Hi, this is Ms. Paflin, and I will be going over the end of course review for the LEAP 2025 test. So in this activity, you will solve problems using skills learned in Essentials of Algebra and Algebra 1. In this video segment, I am going to go over session 1A, non-calculator, where you would get 25 minutes to complete this without using a calculator. And these are numbers 1 through 8 in this review. So for number 1, determine all zeros for the function f of x equals x squared plus 2x minus 8 times x minus 6. Select each correct answer. So for this one, I would first want to set my different standard form and factored form equal to 0. So for this one, I'm going to take x squared plus 2x minus 8 equals 0. Because when we are finding our zeros, that's when y equals 0. So if f of x is our y value, we have to set it equal to 0. Now I need to factor this. So I need to find a factor that multiplies to negative 8 and adds to positive 2. So that would be 4 and negative 2. So it would be x plus 4 times x minus 2 equals 0. Now I need to set each of these equations equal to 0. So x plus 4 equals 0 and x minus 2 equals 0. And then I would solve for x using the inverse. So if this is plus 4, I have to subtract 4 from both sides. 0 minus 4 equals negative 4. Over here I have x minus 2, so I need to add 2 to both sides. 0 plus 2, x equals 2. And then I also need to come back up here to my x minus 6, put it equal to 0. Inverse of minus 6 is plus 6, x equals 6. So these would be the three zeros of my solution, negative 4, 2, and 6. So I would go up and I'm going to cross out any of the ones that are not. G, I. So the correct answers would be letters D, G, and I. All right, number 2. Graph the solution set of 2x plus y is greater than 6. Graph the solution set of the linear inequality in the coordinate plane by graphing the line and shading the desired region. So I first want to get this into slope-intercept form. Y equals mx plus b. So I want to rearrange this equation. If I have 2x plus y is greater than 6, I need to move this 2x over to the other side by doing the inverse, minus 2x to both sides. So that cross cancels. I get y is greater than negative 2x plus 6. I can't combine these because they're not like terms. 6 is a constant and negative 2x has a variable. So then I just write it with my mx first, so that would be my negative 2x, and then my plus b, my plus 6. All right, now I can graph it by first plotting the y-intercept, which is your c value. So 0, 6 would be my y-intercept. So I would put a point at 0, 6. Then I can also find my slope from my m value. So my slope equals negative 2. And then if I create a fraction, I put it over 1, that's my rise over run. So then from my starting point, I know I go down 2, right 1. Down 2, right 1. 2, right 1. And I just keep going until I run out of space. Then I want to connect my line. Now I have to look back at my inequality symbol for how I connect it. And I see that it's a greater than. This would be a dashed or dotted line. because it doesn't have the or equal to. So the dotted line shows that if it's on the line, it's not equal to. It has to be greater than this line. So I'd do a dashed line between my points. And then, since it's greater than, I need to shade above the line, all the values that are greater than. So then that would show that all of my solutions are greater than the line. Number 3. Which expression is equivalent to 3x to the 5th power plus 8x cubed minus 7x squared minus 6x cubed? So we have to simplify this and combine like terms. So the first step would be, I see there's this negative, it's subtraction right now, but we want to change it to addition. So we need to distribute, this is like -1 on the outside. We need to multiply everything on this, in this binomial, by -1. So I'm going to rewrite it. 3x to the 5th plus 8x cubed plus, and now I'm going to multiply -1 times 7x squared, which is -7x squared. And then -1 times -6x cubed is positive 6x cubed. Now I can combine my like terms. 3x to the 5th power, there is not another term with the exponent of 5. Then I go over to 8x cubed, and I have another 6x cubed. And then there's no other term with -7x to the 2nd power. We don't have an exponent of 2. So now I just have to write these from largest exponent to smallest. So I would put 3x to the 5th power. 8x cubed plus 6x cubed is plus 14x cubed. And then minus 7x squared. So that would be letter C. All right, number 4. Which graph best represents the solution to the system of inequalities? So for this one, you can do a couple different things. Going back to what I did in number 2, you can rearrange these into slope-intercept form. And you can also plug in ordered pairs from the 3 graphs to check if it is a solution. So I'm going to show you both methods. So first I'm going to convert these to y equals mx plus b. So this first one, x plus y, is less than or equal to 6. I need to move this x to the other side. So if it's positive x, the inverse is negative x to both sides. Then you get y is, so these cancel out. So I just get y is less than or equal to negative x plus 6. And then for this one, my m is -1 over 1. And my b value, or y-intercept, is 6. So then I'm going to go and check to see which lines. So I know it's not these two because neither of them have a y-intercept at 0, 6. So I can eliminate those options. So now I know it's between C and D. So notice how the shading's a little different here. So let's check. They both have a point at 0, 6, and then this one should be going down 1, right 1, down 1, right 1, down 1, right 1. Okay, so that one's correct. So now I have to look at the shading, because the shading's different on these two. So if it's less than or equal to, it should be shaded all down this line. So I have to see where the shading overlaps. So right now I'm just going to do this so I can check where the shading overlaps. Okay, so there's that one. So it's going below this line. I messed up a little there. Okay. Now for the other equation, x plus 2y is less than or equal to 8. Again, I need to subtract x from both sides. I get 2y is less than or equal to negative x plus 8. And then I need to, if this is 2 times y, I need to do the opposite. Divide by 2 to both sides. So then I get y is less than or equal to negative 1/2 x plus 4. All right, for this one, my slope is negative 1/2 and my y-intercept is 4. So, and then I know it's less than or equal to. So this one is showing the y-intercept at 0, 4. So I know it can't be this one because this one's showing it at 0, 8. So I know it's not that one. But to double check and make sure, and then it would be less than, so it'd be all this area. So this would be the double shaded region. To double check though, you can also plug in values for x and y. Get ordered pairs from the shaded region. So let's just double check an ordered pair from this one that maybe isn't in this one. So like for example, 6, 0 is on the line, but like this one is not, just to make sure we chose the right graph. So if we take 6, 0, we're going to test point 6, 0. So I'm going to plug it into my original equations. 6 is my x, 0 is my y. So up here I'm going to do 6 plus 0 is less than or equal to 6. 6 plus 0 is 6, which is less than or equal to 6. So that checks out. Then I need to plug it into my second equation. 6 plus 2 times 0 less than or equal to 8. 2 times 0 is 0. 6 plus 0 is less than or equal to 8. 6 is less than or equal to 8. Checks out. My answer is D. And you can always plug in a couple more just to make sure. All right, next page. Number 5. Use the information provided to answer part A and part B for question 5. Let A represent a non-zero rational number and let B represent an irrational number. Which expression could represent a rational number? All right, so going through these, just to write, A is a rational number and B is an irrational number. So if we have negative b, that would be a negative irrational number. That still is irrational, so it can't be that one. A rational number plus an irrational number, well, anytime you add an irrational number to any type of number, it's going to be irrational, so that wouldn't work. A rational number times an irrational number will also give you the product of an irrational number, so that one can't be. And then an irrational number squared. Well, let's test this out because it is our last option, but we want to make sure. So let's say the square root of 2. That's an irrational number. Let's say that equals the square root of 2. And then we want to do b squared equals the square root of 2 squared. And then if we simplify this, 2 squared equals the square root of 4, which equals 2. So that is a rational number, so D would give us a rational number. Part B, consider a quadratic equation with integer coefficients and 2 distinct zeros. If one zero is irrational, which statement is true about the other zero? Well, if we go back to how we solve for our zeros in equation, we usually get, the square root of a number. So if we, let's say, got for our 0, x equals plus or minus the square root of 2. Well, if one of our zeros is irrational, one of ours would be positive square root of 2, then the other would be the negative square root of 2. So the other 0 must be irrational, because remember, when we get down to the square root, it's always the positive and negative of that square root. And if it's irrational, then they both are irrational. Number 6. The figure shows a graph of the function f of x in the coordinate plane. A second function g is defined by g of x equals negative 3x plus 2. Select the correct phrase from each list to complete the sentence. So this one's f of x. It gives us the graph. And then g of x is negative 3x plus 2. So I'm going to graph this on my coordinate plane to help me compare the two. So going back to mx plus b, our b value is our y-intercept. So if b is 2, our y-intercept is at 0, 2. Then my m is my slope, which is negative 3. And if we make it into a fraction, negative 3 over 1 is our rise over run. So from this starting point, I'm going to go down 3, right 1, down 3, right 1, and then the opposite direction, up 3, left 1, up 3, left 1. Then I can connect my points. All right, now I can compare and fill in the blanks. So f of 2, which is the line that was already drawn on the graph. So 2, my number inside the parentheses is my x value. So this is when x equals 2. So I'm going to go and put a point. So when x equals 2, I have a point at 2, 8 on f of 2. So that's where y equals 8. So f of 2 equals 8. And then g of 2 would be down here at negative 4. 2, negative 4. So g of 2 equals negative 4. So I'm comparing 8 to negative 4. 8 is greater than g of 2. So f of 2 is greater than g of 2. All right, then looking at the other one, f of negative 2. So now I go over to negative 2. For f of 2, it's at 0. F of negative 2 equals 0. And then g of negative 2 equals 8 up here. And 0 is less than 8. All right, number 7. The cost to manufacture X pairs of sunglasses can be represented by a function c of x. Select from each list to correctly complete the statement about function c. So let's just take some notes from this. C of x. So I know my value inside the parentheses is your x. So if x equals 4, it says that's the pairs of sunglasses. So that would be 4 pairs of sunglasses. And then it's equal to the cost. C of x equals the cost. And in this case, it's equal to $398. Number 8. A circular pool of water is shrinking as it drains. The diagram shows the shrinkage. So for this one, it gives you a formula for the area A of the circular pool is given by the equation A equals pi times r minus 3 squared, which is the formula for r. So we have to rearrange this and solve for r. So I'm going to put A equals pi times r minus 3 squared. So I have to do the inverse. I have to do the opposite. So going back to the whole do and undo, if I were to just solve for A, I would first subtract 3 from R. Then I would square the term. And then I would multiply by pi. We have to do the undo, though. So to undo, we do the opposite. We would first divide by pi. So I'm going to go over here and divide both sides by pi. So a divided by pi equals r minus 3 squared. Now, if the second step would be square the term, I have to do the inverse of square. I have to do the square root of the term. So square root both sides. And then I'm going to write this first, so I would get r minus 3 equals the square root of a divided by pi. All right, then go back to subtract 3, because we're going in the opposite order. So subtract 3, we need to do the inverse. We would add 3 to both sides. So plus 3, r equals the square root of a divided by pi plus 3. And that would give us